this is the homework support for chapter 3, motion in two dimensions. And this is a little bit more complicated than motion in one dimension, because here you have motion both along the x-axis and the y-axis, as you can see here. So you have to treat the motion along the x-axis and the motion along the y-axis as being independent of each other. And the most important thing to remember is that gravity or acceleration due to gravity affects only the y component. So the x component of the velocity never changes. Let me stress that again. The x component of the velocity never changes. And it's only on the y component that the acceleration due to gravity acts. So to start with, we need a little bit of trig, and here I am illustrating that with a right angle triangle ABC, and let's assume that AB is the initial velocity, which I call V naught. So that's a vector, and its value could be 10 meter per second or 15 meter per second. That's the initial velocity with which you throw something. And it is thrown at an angle theta with the horizontal. So it's you are throwing something at an angle to the horizontal. And from the definitions of trig, we see that AC by AB, AC is the adjacent side, AB is the hypotenuse, so AC by AB is cosine theta, which means AC is AB cosine theta. And likewise, BC by AB will be sine theta because it's the opposite side. And sine theta is defined as opposite side by hypotenuse. So once again, rearranging that, we get BC is equal to AB sine theta. So now let's assume that AB has a value of 10 meter per second. It's like 10 meter per second. And so, and theta is 40 degrees. If that's the case, then AC is 10 cosine 40, which gives 7.66 meter per second. And BC is 10 sine of 40, which gives 6.43 meter per second. So that's what you do first. Whenever you're given a velocity at an angle, you break it up into its x component and the y component. So that's the first thing you have to do. And then treat them as independent of each other, like I'm going to show you on the next page. So here is an actual object that is thrown, maybe a stone that is thrown with that velocity, the same velocity as before, thrown at 10 meter per second. And we already found that these components are 7.66 and 6.43. And what we're trying to find is how far away does this stone hit the ground? So how far away does it hit the ground? So it starts from A, it ends at B, and we want to see how much the distance AB is. And since that's a distance along the x-axis, we will call it delta x. So we're trying to find how much delta x is. Now to find how much delta x is, all we got to do is multiply the 7.66 with the time it takes to go from A to B. Multiply the 7.66 with the time. But we do not know the time. So first we have to find the time. Now to find the time, we take the vertical component. We look at the y quantities, only the y quantities. We know that the delta y from A to B is 0 because it starts from the ground and ends on the ground, right? It starts from the ground, ends on the ground. It does not move vertically. And so delta y is 0. And then we also know that VOY, V initial y, is 6.43. And the acceleration is negative 9.8 meter per second squared, as always. And then we have to find time. So time question mark, and we see that the equation to be used is delta y is v naught t plus 1/2 at squared. When you substitute into that equation, you get 0 is 6.43 t minus 4.9. And now you get minus 4.9 because 1/2 times 9.8 is 4.9. So rearrange that equation and solve for t. I brought this to the other side, and then one of the t's get cancelled. And then finally you get time as 1.31 seconds. So now you know that this projectile takes 1.31 seconds to go from A to B. So now to find delta x, all we got to do is multiply that time with this constant velocity, because that velocity along the x is not affected by gravity. It stays the same. And so to find delta x, you just multiply that velocity, 7.66 meter per second, with the time of 1.31 seconds. And when you do that, you get 10.03 meter, and that's how you work out this problem. Now, here's another question where a person is walking 4 kilometers to the north and then walks 5 kilometers to the east. 4 kilometers to the north and 5 kilometers to the east. And the question is, how far away is the person now from the starting point? Or in other words, how much is this? Now, it's a right angle triangle, so to find this, all you got to do is apply the Pythagoras theorem. And when you apply the Pythagorean theorem, you're going to get the displacement. But remember that the distance is just 4 plus 5. See, the distance, total distance that this person has walked is 9 kilometers. But the displacement is, of course, less than that. Because displacement is the straight line distance from the starting point to the finishing point. And for that, you find root 4 squared plus 5 squared, which gives you 6.40 kilometers. So that's the displacement. So here you see the difference between distance and displacement. To find the distance, you actually measure all those distances that you moved. But to find the displacement, you take the straight line distance from the starting point to the finishing point. And then to find the angle theta, use the trig, and tan theta is opposite side by adjacent side. This is the angle, so this is the opposite side to the angle. This is the adjacent side. So when you apply tan theta is equal to 5 divided by 4, you get it as 1.25, and then you take the inverse of that, inverse of 1.25, to give you the angle as 51.34 degrees. So that's how you work it out. I'm doing a more complicated problem at the end, so it'll become all the more clear, but I wanted to start off with an easier one. I know this chapter is a little bit more complicated because it has both the x and the y components coming in, and you got to be really careful to separate them. Anyways, let's move on to the next one. Here is a swimmer swimming straight across a river, or that's the intention, but the water is flowing down at a certain speed, and the swimmer is trying to get across directly, But we know that the swimmer will not be able to reach the opposite side of the bank. The swimmer is going to be carried down by the water and they're going to reach somewhere here, right? So assuming that the water is flowing at 4 meter per second and the swimmer can do 3 meter per second, we can find the time it takes for the swimmer to get across if the width of the river is given. Let's take it as 150 meter. And so the time taken, time is just distance by the velocity. So here you see, divide the displacement along the y-axis with the y velocity. See, that's along the y. This velocity is also along the y. So you get 150 divided by 3. This person is going to take 50 seconds to reach the other side of the bank. And what is interesting is that whatever is the speed of the river, whether it's 4 or 5 or 7 or 15, it doesn't matter. The swimmer is going to take 50 seconds to reach the opposite bank. Isn't that interesting? But what's going to happen is, if the water is flowing faster, then the swimmer is going to be carried more downstream. So now we're going to look at the x and apply the same idea. The idea is that BC is going to be the x velocity multiplied by the time that we got. So the x velocity is 4 meter per second multiplied by the time, 50 gives us 200 meters. So the swimmer is going to be carried downstream by 200 meters. If the river was flowing faster, the time taken across is still 50 seconds, but the swimmer will be carried more downstream. If it's 5 meter per second, the swimmer will be carried downstream by 250 meter. So I hope that makes things more clear. What's important is to remember to keep the x and the y separate from each other. All right, let's move on to the next one. Now, in this case, a person is walking in so many different directions, or maybe sailing in a boat. So first the person walks 2 kilometers, 45 degrees north of west. So what do you mean by north of west? So west is to your left, and then you have to go 45 degrees to the north. So when you say north of west, you start from west and move 45 degrees to the north. So that's what the person does first, and then walks 4.5 kilometers, 60 degrees south of east. Now what is south of east? So you start from the east, which is to your right, and then move 60 degrees to the south. Start from the east and move 60 degrees to the south. And then the person goes 5 kilometers straight east, just like that. And then 7.0 kilometers, 55 degrees south of west. So now it's from there south of west, okay? And finally, the person walks or sails 3.0 kilometers, 5 degrees north of east. So we got to draw a diagram to illustrate this. So that's the first one. This is 2 kilometers, 45 degrees north of west. And then you have 4.5 kilometers, 60 degrees south of east. Remember, start from east and go 60 degrees. So that's why the line is inclined that way. Okay, 60 degrees south of east. And then the person walks 5 kilometers east. So straight east from there. And then number 4, 7 kilometers, this one, 55 degrees south of west. So start from the west and go 55 degrees to the south. Finally, at 5 degrees north of east, just a little bit north of east. That's coming up here. So let me label them as A, B, C, D, E, F. And then what you got to do is you need to break it up into its components. So I'm just labeling A, B, B, C, C, D, D, E, and E, F as shown. And then you have to break each one into its components. So here is the first one broken up. Take it back a little bit. So that's the first one. This vector is broken up into its X and its Y. See that? And then the next vector is broken up. This one is broken up into its Y, into its X. See where I'm stopping it? Look at that. It should be stopped right there. And even here, see how I line it up, okay? Diagrams make a big difference in physics, so please learn to draw them clearly. And the next one, of course, has no components because it's straight east. It's only along the X. It has no Y. And then the fourth one, this one has to be broken up into, you're going to get something along the X, and then you will get something along the Y, okay? That's the X, and then you have the Y. And finally, you have this little one broken up into its two components. That's the Y, that's the X. All right, so now what you got to do is, don't be overwhelmed. It's the same process. Once we got to find the components now. How do you find the components? You got to know that the angles are given here. For example, it's 45 degrees. Let me use 45 degrees is this angle north of west. Okay, so we know this is going to be 2 cosine 45. This is 2 sine 45. And whatever you take the angle with becomes the cosine. So since you take the angle with the x, see, that becomes 2.0 cosine. This becomes 2.0 sine. All right, so here are the numbers that I'm writing now. This is 2.0 sine 45. And then this one is 2.0 cosine 45, right? Do the same thing with the other ones. This angle is 60, so since we're taking the angle with this is going to become cosine. That'll be 4.50 cosine 60, and the other one will be 4.50 sine 60. Are you tagging along nicely? So do the same with the others. This angle is 55, so this is going to be 7.0 cosine 55. Then 7.0 sine 55. Whatever you take the angle with will be cosine, the other will be sine. So once you get all the x and the y's, here are the x components. Now you see that some of the x components are positive. To the right is positive, to the left is negative. And here actually I'm writing the numbers. I put this into the calculator. I did 4.50 times cosine 60 and I got 2.25. And then similarly I did 2.0 times cosine 45. I got 1.41, but I know it's negative because it's to the left side, right? So that's how I'm getting all those numbers. And then you have the 5, then you have the minus 4 plus 2.99, and when I do all that, I get 4.83. So now here are the y components. Again, up is positive and down is negative. So I do that and I get the total y as negative 7.94 kilometers. So here I've drawn the total x and the total y. Okay, 4.83 and negative 7.94. And my diagram is not perfect because if it was, then this line that I've drawn here should have been parallel to this one because it's the same line, and you can see it's not. So forgive me for that. It's quite tough to draw it, but the idea is there. This is the total x, this is the total y. Once you get that, you can find the total displacement and also the angle. Now, to find the total displacement, you use the P theorem. Take the square root of the sum of the squares, and you calculate that to be 9.3 kilometers. And then to find the angle, tan theta, you go opposite side by adjacent side. So 7.94 by 4.83. Clearly, I'm not using the negative. You need not. You get 1.64. And when you take the inverse of that, you are going to get the angle as 58.68 degrees. Which brings us to the last one. Whew, that was a process, but I hope you will pause and that you will go back over these steps and make sure that you understand, because these are the type of problems that will be on the exam, because you also get to do them on the homework, and I'm assuming that once you watch this, do it on the homework, I could test you on this. All right, that's a pointer in the right direction. So here's the last question. A ball can be thrown to a maximum distance of 100 meters. Now, whenever you see this word maximum distance, to throw something to a maximum distance, you have to project it at an angle of 45 degrees. That's very important to know. So if in a problem you see something can be thrown to a maximum distance, then you know that the angle of projection is exactly 45 degrees. And you're asked to calculate the initial velocity of the ball. And also you're asked to calculate the maximum height to which it can go. So as the ball travels, as it moves, what's the maximum height it reaches from the ground? Okay, so it goes that way, and then what's the maximum height? So you got to calculate two things: the velocity with which the ball was thrown and the maximum height to which it goes. Let's do it step by step. Now, to find the initial velocity, remember that the angle of projection is 45 degrees. Okay, so here's the diagram. We do not know the initial velocity, but we know that the angle is 45 because it says maximum distance. And then you take the components. This is V naught cosine 45, and cosine 45 is 0.7. The other one is V naught sine 45, and sine 45 is also 0.7. So don't be confused with that. So I know that to get the maximum x, the x distance, let me take this back. To get the x distance, all you got to do is multiply the x velocity, which this one, with the time. But the problem is we do not have the time. Okay? But this is, I hope, very clear. The x distance is always the x velocity multiplied by time. So now we got to find the time. To find the time, we look at the vertical quantities. And we know that delta y is 0. Once again, it's starting from the ground and reaching the ground, so it doesn't go anywhere. When you take the total path, delta y is 0. And the initial along the y is 0.7 v naught. Acceleration is negative 9.8 meter per second squared. I've said that 100 times. And we're trying to find time. So the equation is delta y is v naught t plus 1/2 at squared. And plug it into that. 0 is equal to 0.7 v naught. And again, 1/2 times 9.8 is 4.9. And the negative is because it's negative 9.8. And so rearrange that. And I forgot the t there because you got to have v naught times t. Now, because there's t there, you can cancel the t squared and the t. And then you get the time as 0.7 v naught by 4.9. Divide 0.7 by 4.9, you get 0.14. And substitute that in place of this t here. Okay? Which is what I'm doing next. So 100 is 0.7 v naught multiplied by the t. And then you can see that there's only v naught in this. So you get v naught squared. And then you got to find v naught. First divide 100 by 0.098. And then take the square root, of course. When you do that, you get the initial velocity as 31.94 meter per second. Next, we need to find the maximum height. What's the maximum height it reaches? So when you look at the maximum height, you know that the vertical component of the velocity, it becomes zero at the highest point. So it starts with a certain value, I'm talking about the vertical, and it decreases and becomes zero at the top. So we know that the final vertical velocity at the highest point is zero. That's the important point that you have to remember here. So once you remember that, we can do this easily. At the maximum height, the vertical component of the velocity, which is Vfy, not V naught, Voy, I'm going to change that. V final y at the highest point is 0. And and A is negative 9.8 meter per second squared. Initial velocity, we already found it, it's 31.94. Hold on a minute. So I'd have already found it. I had made a mistake, so I had to correct it. VOY is not 31.94. It's, remember, 0.7 times 31.94, which actually gives 22.6. So when you substitute it into this equation, Vf squared is V naught squared plus 2a delta y. This is 0. This is 22.6 squared. And then 2 times 9.8 times delta y. You get 510 here, negative 19.6 here. Rearrange that, and again. So this is 510. Sorry for that. And then when you divide 510 by 19.6, you get 26 meters. So that's how you find the maximum height. Thank you, and I hope this has been useful. Although it's a struggle, try to pause, think, understand. If there are questions, ask me in class or send me an email. Thank you.